right, in this lesson we're going to talk about the vertex form of a parabola. A function is a quadratic function if it can be written in the form ax squared plus bx plus c. So I see up here that the biggest degree I have is a 2. That means it's going to be quadratic. All right, all quadratic functions are transformations of its parent function, which is f of x equals x squared. And the vertex form that we're talking about today is a times x minus h squared plus k, where hk is the vertex of the parabola. Vertex form is useful because you can get the vertex right from the function, which also gives you the axis of symmetry. Number 1, how are the transformations of the graph of f of x equals x squared related to its parent function? So I can see down here that inside here I have added 2, and then on the outside I have multiplied by 1/2, and then I have also multiplied by a negative. When you multiply by a negative, that's giving you a reflection. When you multiply by a number, that's going to give you a stretch or a shrink. So let's start with the negative. Since it's on the outside, I know that that's something vertical. So this is going to be a reflection over the x-axis because going over the x-axis is something vertical. It affects our y value. So reflection over the x-axis. Okay? When I multiply by 1/2, again, that's on the outside. So multiplying by a number gives me a stretch or a shrink. Since it's on the outside, I know that this is going to be a vertical. Since it's less than 1/2, that would be a shrink by a factor of 1/2. And then inside the grouping symbols, I am adding 2. So that means I'm going to move left 2. So on part B, I see that I'm subtracting 3 outside, subtracting 1 inside, and multiplying outside by a 2. So multiplying outside is going to be something vertical. So this is a vertical stretch, since it's bigger than 1, by a factor of 2. Inside, I have subtracted 1, so that means I'm going to move right 1. And outside, I have subtracted 3, so I'm going to move down 3. All right, moving on to number 2, part A. I see that I have multiplied outside by 0.4, and on the inside I have subtracted 3. 0.4 is between 0 and 1, so I know that this will be a vertical shrink by a factor of 0.4. And since this is minus 3 on the inside, I know that that's going to move me right 3. All right, part B, I'm adding 2 on the outside, subtracting 1 inside the group, and multiplying by 3 on the outside. So when I multiply on the outside, that's going to be a vertical bigger than 1, so stretch by a factor of 3. I also know that I'm subtracting 1, so that's going to move me right 1. And I'm adding 2 outside, which means that's going to move me up 2. What are the key features of the quadratic function? I have my vertex form here. I know immediately I can tell what the vertex is. So remember, the vertex is going to come from the h and the k. So if you think about our little format here, x minus h squared plus k, I know that behind the minus sign is my h value. So behind the minus sign is 3, so 3 comma, and then the k is whatever is here at the back, which is a positive 4, so 3, 4. I also know that my axis of symmetry, which I'm going to abbreviate as the AOS, is x equals, it's a line, it's x equals the x value of my vertex. So x equals 3. So I have my vertex and I have my axis of symmetry. When I look at the number in front of the equation, in other words, the a value, it is positive. If that number is positive, it's going to open up. So if it opens up, it makes like the letter U, and it has a minimum. If it opens down because it's negative, then it would have a maximum. So I know that this has a minimum because it opens up. So the minimum is going to be where the y value is of the vertex. So the minimum here would be 4. Okay, let's talk domain and range. We already know that quadratic functions are a U-shape. So they shoot off to the left and to the right, and we really don't have any restrictions as far as the domain goes. So for our domain, it's just negative infinity to positive infinity. We could also call that all real numbers. All right, but I know that this opens up, and its vertex is here at 3, 4. So the lowest this graph is going to go is 4, and then it's going to go up. So for the range, the lowest our graph is 4, and then I can have any y value that goes up. So all of mine have to be greater than or equal to 4. All right, so we're supposed to identify the vertex, axis of symmetry, minimum or maximum, domain, and range of the function, just like we did on number 3. So I see that this function is going to open downward, which means it's going to have a maximum value there at the top. Okay, so let's start with the vertex. The vertex is always h comma k. So this plus right here means that this would have been minus a negative 4. So behind the minus, I have a negative 4. You can also think to yourself, it needs to be opposite. And then we have this minus 5 at the back. So that means my axis of symmetry is going to be the line x equals the x value of my vertex. Since this opens downward, I have a maximum. And remember, you're going to state that as the y value of your vertex, which would be negative 5. That's the highest it's going to go. The domain, again, this is a U shape. So I know that my domain is negative infinity to positive infinity, or just all real numbers. And my range, since this opens downward, it's all of the negative values all the way up to this top part, which would be negative 5. So this goes from negative infinity all the way up to negative 5, and there we are included. What is the equation of the quadratic function with vertex negative 2, 3, and y-intercept negative 1? Well, if I have a y-intercept, that means the x value is 0. So the point at the y-intercept would be 0, negative 1. We're supposed to write this in vertex form. So remember, vertex form is a times x minus h squared plus k. Well, I know that the h and the k are my vertex. So they gave me the vertex right here. That means that h is negative 2 and k is 3. So h is negative 2 and k is 3. Now, the only thing I don't have for my formula is the a, because when you write the equation, the y and the x remain y and x, but I need a. So that's why they gave me this extra point right here, the y-intercept. I can plug in for x and y and solve for a and then write my equation. So that means that this would be the x and this would be the y, just to find my a. So x is 0, y is negative 1. So I'm going to plug in to this right here and solve for a. So my y value is -1. I don't know the a. And then I have x, which is 0, minus my h value. Well, h is -2, which means this is going to make this positive, squared plus my k value, which is 3. And now I'm just going to solve. Well, I have a times this. Well, 0 plus 2 squared would be 2 squared, which is 4. So this is a times 4. Well, we would write that as 4a plus 3. So now I'm going to solve. I subtract 3, which gives me -4 equals 4a, divide by 4. So I know that a is -1. So now I just take and write my equation. I'm going to use function notation. So f of x equals, my a goes first. So -1. Now, since it's -1 times something, I'm not putting the 1. I'm just going to put the negative. And then x minus my h value, which is -2. So again, that makes this plus 2 squared plus k, which is 3. And that is the equation in vertex form. All right, so again, they gave us the vertex. So I know that h is 1 and k is -4. And then they gave me a point that I'm going through. So they don't give me the a, which means I'm going to have to find that. This will represent my x and my y. Always identify your h and k first. That way you know the other point that it's passing through will be your x and y. And you only need that to find the a. So we have y equals, so -1 equals a, which I don't know, times x, which is -2, minus h is 1, squared plus k. Now, this is plus -4, so I'm just going to put -4. Now we need to find this part right here because this is being multiplied by a. We have -2 minus 1 is -3. Squared is 9. So this would be a times 9. So 9a minus 4. I'm going to add the 5. Oh, that's a 4. So add the 4. That gives me 3 is equal to 9a. Divide by 9. 9 divided by 3 will reduce to 1/3. So a is 1/3. Now I'm ready to write my function. F of x equals a, which is 1/3, times x minus my h value, which is 1, squared, plus k, but k is -4, so this will be -4. The height of a thrown ball is a quadratic function of the time it has been in the air. The ball is hit with an initial height of 4 feet, and after 1 second reaches its vertex at 20 feet. What is an equation that defines this function? Write the quadratic function in vertex form and in the form y equals ax squared plus bx plus c. So first things first, we're going to have our vertex, and we're going to have another point in order to write the graph. And we'd like to have a, but we don't know what a is. So it says that my ball is hit with an initial height of 4 feet. That means it's 4 feet up where my ball is hit. So obviously there's a person holding the ball. That would represent before my ball was hit. Therefore, that's my y-intercept. So no time has passed. All right. And it's at a height of 4 feet. All right. Then it says it reaches its vertex at 20 feet, and that happens after 1 second. So my vertex is 1, 20. So this is my vertex, and this is just an extra point. So I know that the vertex is the HK, and this is going to represent the XY to find my equation here. I got to find my A. All right, so my y equals, that'd be 4 equals A, which I don't know, times X minus my H, which is 1, squared, plus my K, which is 20. So first, I need to figure out what I'm multiplying a by. 0 minus 1 is negative, 1 squared is 1. So 1 times a is just a. So I'm going to subtract 20. And I get that a is negative 16, which makes sense because if you hit a ball, you're going to hit it, it's going to go up and then come back down. So a should be negative because this parabola is opening down. So now I have f of x equals negative 16 times x minus h, which is 1, squared, plus k, which is 20. Now, this is my vertex form. Now it's asking me to write it in the form y equals ax squared plus bx plus c. It means to literally take your vertex form and simplify it, like put it all together. So I see that I have x minus 1 squared. That would be x minus 1 times x minus 1. So I need to multiply the x minus 1 and the x minus 1 together. I'm going to leave this negative 16 out front for a second. So x times x is x squared. X times negative 1 is negative x. Negative x times, or negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And then the two middle terms are going to end up combining because they are like terms. Negative 1x and negative 1x make negative 2x plus 1. So now I multiplied the x minus 1 times the x minus 1. So now I have negative 16 out front and the plus 20 at the back. Now I need to distribute the negative 16. So I have negative 16x squared. Negative 16 times negative 2x is positive 32x. And negative 16 times 1 is negative 16. And then I still have that plus 20 there at the back. So I'll combine my like terms back here, and I get negative 16x squared plus 32x plus 4. And there is my function written in what we will find out later is standard form. The graph shows the height of a ball with respect to time. What's the equation of the function? Write the equation in vertex form, then write the equation in the form y equals ax squared plus bx plus c. All right, so again, I need my vertex, and I need the initial height, or another point. I mean, it really doesn't matter, any other point on the graph, because I don't have the a value, and I need that. So looks like my vertex is 210. So that means that the h is 2 and the k is 10. This other point will be the x and the y. I could use this point too if I wanted to, which is the point 4, 4. Okay, I just need any other point on there. So y equals, that'd be 4 equals a, which I don't know, times x, which is 0, minus h, which is 2, squared, and then plus k, which is 10. Now, I see that this is opening upside down, so I know that my a should end up being negative. So let's check out what we're multiplying a by. 0 minus 2 is negative 2, squared is 4, so this is a times 4, which is 4a. I'm going to subtract 10. That gives me negative 6 equals 4a. Divide by 4. So a is equal to negative 3 over 2. So my function would be f of x equals a times x minus h, which is 2, squared plus k. So there is your vertex form. Now we're going to multiply this out so that we can get our standard form. So first things first, you're going to take the x minus 2 and square it. That means you have to do x minus 2 times x minus 2. So we have x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Your two middles should combine. So now we have x squared minus 4x plus 4. I still have to take that times negative 3 halves. And then I still have that plus 10 there at the back. So I distribute negative 3 halves. That gives me negative 3 halves x squared. Negative 3 halves times negative 4 would be a positive 6x. And then we have negative 3 halves times positive 4 would be a negative 6. And then we still have this plus 10. So negative 3 halves x squared plus 6x, and then a negative 6 and a positive 10 make positive 4. Put your function notation in front, and that would be the standard form of your equation. What is the equation of j? Write the equation in vertex form and in the form y equals ax squared plus bx plus c. So it says we have j that's going to be a quadratic function whose graph is a translation of the parent function. Remember, the parent function is x squared. 1 unit left and 3 units up. So we're going to start with the 1 unit left. I know that that should be in the group with the x because it's a horizontal motion. Now, if I'm going left, that means I'm going to add the 1. So there is my parent function moved 1 unit left. Now, that was the first one. All right, the second one. Now I'm moving 3 units up. Well, that means that that just gets added to the outside. So I'm going to take what I had after my move to the left, and I'm going to add 3. So my function would be x plus 1 squared plus 3. And you can use a graphing calculator to graph the parent function and then what you got after you did the translations and see if it moves left 1 and up 3. All right, part B. We are doing 2 right and 5 down. So 2 right means I'm going to go inside, make a group, subtract 2, and then squared. So that is the first step. The second step, then I'm moving 5 down. That should be on the outside. So I take what I originally had and subtract 5. So our function would be f of x equals x minus 2 squared minus 5. All right, part C. It says, let j be a quadratic function whose graph is a reflection of the graph of the parent function f in the x-axis, followed by a translation 1 unit down. So first, we're going to do a reflection over the x-axis. That means on the outside, we're going to take and multiply negative x squared. So we do that first. Then it says we have to go 1 unit down. So the second thing we do is we take our entire function and we subtract 1. And I have been reading these as j and then writing them as f. So this is j of x equals negative x squared minus 1. All right, now if this would have been a horizontal, you would have done a negative x squared if you wanted to go over the y-axis, okay? All right, so let's change these to j. Now it did tell us to write all of these in the form ax squared plus bx plus c, so let's go ahead and do that. I have my x plus 1 squared, so x plus 1 times x plus 1. So we have x times x is x squared, x times 1 is x, 1 times x is x, and 1 times 1 is 1, and then we still have that plus 3. And then I'm going to go ahead and put my notation in the front and combine my like terms. So I have x squared, 1x, and 1x makes 2x, and then 1 plus 3 is 4. Now there is kind of a shortcut here. If you will notice, it's always x times x, which ends up being the number in the front. And then the 1 times the 1 at the back always ends up being the 1 at the back. And the middle is literally just the two numbers multiplied together and doubled. So let's try that on this one. We have x minus 2 times x minus 2. Now you could distribute and go through all of that, or you could say it's going to be x times x is x squared. And then the middle is always, there's always two of them because it was squared. So you have negative 2x and negative 2x. That's negative 4x. And then negative 2 times negative 2 is positive 4. And then you have your minus 5 back here. So j of x is equal to x squared minus 4x minus 1. And then on this bottom one, it is already written in the format of ax squared plus bx plus c. So we don't have to do anything else with that.